In this experiment, you'll be practicing preparing volumetric solutions, transferring solutions with a volumetric pipette, and performing volumetric dilutions. There are only a couple of safety considerations for this lab. One is the standard glassware safety, where you should be aware of any chips or cracks in your glassware and that kind of thing. The other consideration is in the use of methylene blue. Methylene blue, also known as 3,7-bis-dimethylamino-phenazothionium chloride, or basic blue 9, is a mildly toxic, mild skin and eye irritant. So you should avoid ingesting it and avoid spilling any on your skin or getting any in your eyes. If you do, you should simply rinse with copious amounts of water. In general, I expect that your bigger concern will be that methylene blue is a dye, and as such, it will stain your skin and stain your clothes if you manage to spill any on you. To start the experiment, you'll need to make a stock solution of methylene blue. You'll need to weigh out exactly approximately 0.07 grams of methylene blue into a dry 150 ml beaker, and then you'll dissolve the dye using a small amount of distilled water. Roughly 25 milliliters will be fine. The exact volume isn't important. You can stir with a glass rod to dissolve it if you need to. And then you're going to prepare a 100 milliliter volumetric solution according to the steps in either the introduction to this experiment or in the video on preparing a volumetric solution that should be in this playlist. Very briefly, the way this is done is you will take your small amount of dissolved methylene blue, you'll transfer it using a funnel and a glass stirring rod into a volumetric flask, and then you'll add water up until the indicator mark on your volumetric flask. And you'll record the volume of that volumetric solution, and that should be 100.0 milliliters. Once you've made your methylene blue stock solution, you'll need to perform a series of dilutions, and you'll do that using volumetric pipettes to transfer some solution and volumetric flasks to make your new diluted solutions. For details on how to use a volumetric pipette, please watch the instructional video on using volumetric pipettes that should also be in this playlist. The way this dilution process works is you'll pour out a small portion of your stock solution into a working beaker and use a 10 milliliter volumetric pipette to transfer a 10 ml aliquot, or a 10 ml portion of that stock solution, into a new volumetric flask. You'll then dilute to the mark with distilled water, just like you did when you made your stock solution. You'll cap your volumetric flask, and you'll do your inversions. After you've done this, you'll have a stock solution and a first dilution. You'll use your first dilution, pour out a small portion of that, pipette a 10 milliliter portion of that into a new volumetric flask, and make it up to the mark with water. And this will give you your second dilution. And you continue that process a third time so that at the end you will have a stock solution, a first dilution, a second dilution, and a third dilution. The calculations for this lab are fairly straightforward. For part 1, all you have to do is calculate the molarity of the methylene blue stock solution. So you can use the mass of methylene blue and its molar mass to find the number of moles of methylene blue that went into your stock solution. You know the volume of your stock solution, and with those two values, you should be able to find the molarity of that stock solution. The second part of the experiment requires you to calculate the molarities of the diluted solutions. You know the initial stock solution concentration because you just calculated it, and you know that you took a 10 milliliter portion of that solution, and because you know the volume that you took and the molarity of that solution, you should be able to find the number of moles that you transferred using the pipette. This number of moles of methylene blue were transferred into a 100 milliliter flask. So you know the number of moles, and you know the volume it was diluted to, and from that you should be able to find the molarity of the diluted solution. To find the concentration of your second and third dilutions, you simply repeat that process. Now your concentration that you're starting with is the concentration of the first dilution. You know that you have 10 milliliters of that solution, so you can find moles. You then dilute that to 100 milliliters, and you can use that to find the molarity. And then you can repeat that process a third time and find the concentration of your third dilution.